So how do we solve a circuit like this? Using nodal analysis. You already know in nodal analysis, the first thing you have to do is to identify the number of principal nodes. And there are two principal nodes here, one at the top and one at the bottom. And from these two principal nodes, we have to assign one as ground or the reference node. So this is our ground node. And then what we do, we usually assign voltages V1, V2, V3, and so on at the remaining nodes. And we only have one remaining node. But one interesting thing you have to deduce from here is that V1 is actually equal to Vx. Why is that? Because Vx is the voltage across this 20 ohm resistor, and as per our assumption, the voltage across the 20 ohm resistor is V1, because as we assign the node voltages, this is 20 ohms, and we had assigned this node to be ground and this one to be V1. So V20 ohms is going to be V1 minus 0 or V1 as per our deductions. And as the circuit is drawn or this Vx voltage is measured, this V1 is exactly equal to Vx. So this is what you have to deduce, and it's extremely important to be able to solve this circuit very fast. And you can see that two currents are already given. One is all entering the node and one is leaving the node, and we are going to assume that two other currents, I1 and I2, are leaving the node. So if we apply KCL at Vx, which is basically V1, we get 2 ampere is entering and everything else is leaving. So I1 plus I2 plus 0.2 Vx. Now what is I1? I1 is this current through this 10 ohm resistor. So this is going to be simply Vx by 10. Vx by 10. I2 is going to be Vx by 20, and then you have 0.2 Vx as it is. So this is the equation you have, and you have to simply solve this. And if I'm not wrong, after you simplify the equation, you should get something like Vx is equal to 40 by 7. And that should be your answer.